Okay, here we go. We are live. Sorry about that hiccup. And here we go. People are showing up. Hi, Carlotta. Can you post in the group that we're at this live stream in case people are confused about the other one not working, please? Hi, Rhea. Hi, Vicky. Hi, Samuel. All right. So, live stream 2. Wow, look at that. People are really showing up. Good job, people. So, Carlotta is here. Rhea is here. Vicky is here. Samuel is here. Emma is here. All right. Friedrich, Lars. Okay. Aaron. Lena. Aaron. Lena. Isabel. Okay. 1, 2, 3, 5, 7, 8, 9, 10. Okay. Still a little low on the attendance, I think. Maybe other people are showing up. Somebody did post in the chat that we're meeting right now. I think Carlotta said that she did. Yes. Okay. Any other people show? Here we go. Some other people, please, as you come into the chat, this live stream, please, Gavin, hi. Can you unban me? Gavin, thank you for reminding us that you were banned from the last chat, but in this one, you're unbanned currently. Okay. 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 All right. I have a list of people who I think should be here who aren't. Let me just read through this list to make sure they're actually not here. Natasha, Ava, Rebecca, Johannes, Rafi, Ada, Molly, Macy, Ella, Philip, and Louisa. I said hi on my main account, but you can see it because I'm banned. Hi, Macy. Okay. All right. So you're saying I banned you from this thing. I don't even know how to do that. Okay, I'm going to try. Teilnehmer, Chat, Zeitstempel. Oh, okay. So Gavin, you may call me Boomer, but I have no idea how to do that. So, okay. All right. So we still have a few people that are not here yet. All right. Okay. So, all righty, people. Now, please refrain from stupid comments. That will be great. Because we're trying to actually do something here that's constructive, hopefully. Natasha, hi. Okay, I hope you're all, hi, Ella. Okay. So I hope you're all well. I hope your families are well. And if anybody's sick, I hope they're getting healthy soon. We have today 45 minutes. Hi. We have today 45 minutes scheduled, and my intention was to do 30 minutes of physics and then have 15 minutes as a homeroom situation. Hi, Ava. Okay, right now I have only Rebecca, Johannes, Rafi, Molly, Philip, and Louisa not here. Well, that's actually quite a few people, but anyway. Okay, so we're already quite a bit into the time. Let's get started on the physics, and then once we hit 12 o'clock, we'll have a few minutes to just chat. Okay, Samuel, this is your last warning before you get banned, Doodle, because your comments are non-constructive. Okay, so we talked last time about a concave lens. And just a quick reminder of what that looks like. Concave lenses look like this. Okay. Here's the optical axis. And hi, Rafi. And we talked about what would happen. Who's Fortnite? And why do you have a name that's not a name? All right. So we talked about the fact that parallel light, that was our rule one. Rule one of concave lenses. Concave lenses. And what we said was we're going to pretend we'll pretend that the light gets broken at the center of the lens as if it were coming from the focal point. That was rule one. We did that last time. Okay, rule one. It is parallel, and it goes to as if from F. There we go. Good. So that's what happens in rule one. Now, just as we had for convex lenses, we're going to generate a rule two. A rule two is implied by the fact that there's a rule one, obviously. And just as we had for convex lenses, hi, Becky. Just as we had for convex lenses, we will have rule two be just rule one in reverse. Okay? So let's take a look at rule one. A parallel light ray gets scattered away from the focal point. Now, how can we apply that as rule two in reverse? Well, just a reminder, rule two comes from the fact that light paths are reversible, which means because light this parallel gets set in this direction, we could also direct the light in the opposite direction. What I mean by that is, instead of taking parallel light that then goes away, if we took light and we sent it at the focal point. So in reverse, the whole thing. All right. Come on. This one, green. Does this one work? Okay. So we send light at the focal point. Then on the other side would come out parallel. Okay. So light that's parallel gets sent out as if it's coming from the focal point, and light that's sent at the focal point becomes parallel. Now, that seems strange that what's going on here in terms of light going in two different directions, because how is this process starting? Just a reminder that the idea is that we're looking at some kind of object. Like here's our object. And we're looking at light that comes parallel and sends this way because we're trying to look at it. So there's an eye over here. This is us trying to look at the situation. And we're saying, okay, well, what do we see? Okay. So what do we see? Well, the second rule being, if you send something at focal point, it becomes parallel. Well, we can use that rule also in terms of how the light is coming from our object here, our object being a red arrow. Okay, we're looking at the arrow, the light coming from our object. The parallel light goes away in this direction. We're going to now take a look at applying the second rule. So the second rule is that we send light at the focal point. It becomes parallel. Now take a look at how we're going to do that. Remember, for the convex lens, we started with light from the tip over there. Okay. It can't work with that keyboard, and you know that. Yeah. Okay. So there it is. So I got it now moved over. So I hope you can see it. So parallel light is going away as if it were coming from the focal point. In the same way, light that is sent at the focal point would come out parallel over here. But we want to have light from the same. We want to have light from the same point here. So we're now going to have to start here. This was rule 1, and we have to take light that follows rule 2 from here. Well, which direction do we send it? And I'll give you 2 options. Because it says light at the focal point. Well, what direction is that? Is that this direction? We'll call this option A. Or is that this direction? And we'll call that option B. We want to apply rule 2 to light coming from the end of this arrow. What option do we want? Which light is the correct light to follow rule 2? A or B? Okay, this is a participatory question. Good. Thanks, Carlotta. Everybody else? Light A or light B? I'm pointing this out because this is the most common mistake for a ray diagram in this situation. Okay, the ray diagram, you might think at the focal point means at the focal point on the same side. That is not correct. It should be going at the focal point on the other side, on other side. Okay, and the same thing applies to rule 1. Parallel light goes out the lens as if it were coming from the focal point on the other side. Okay, so the correct answer is B. Okay, good. So that means B is the right one, so we can eliminate this one right here and follow this light here. Whoopsie. We're aiming at the focal point, and then it would get directed in this direction. Good. Now, all righty, we have now rule 1, we have rule 2, and we've applied our 2 rules, and now we can look for the image. We're looking for the image, and a reminder, where does the image form? Okay, light comes this way, and light comes this way. When you're looking at an object, the object is the place the light comes from. The light diverges from a certain spot. So if you were looking at this actual object over here, here's your eye, you'd be seeing it at this location because that is the location where the light is diverging from. And the fact that light is coming from this point to your eye, this is your eye, whoa, here, indicates that the object is there. Okay, so where does this light come from? Where does it converge? Well, the light here has a point of convergence that is not as obvious. Crap. There we go. There we go. Ah, there we go. Feels good. Much better. Okay. So these 2 light rays that come out of the lens over there is where it would intersect. That's correct, Carlotta. So we take a dotted line back and we see, well, it's maybe a little bit too slightly dotted, that over here is where the light appears to be converging, or where it appears to be coming from. That's kind of weird, and I'm going to draw this in a different color to just make it clear what's happening here. We have our image forming here. This is the image. Okay, that's the image that formed. And of course, it wouldn't be green, it would be red. Okay, so the red arrow here will create an image right there that we can see from over here. Let's classify that image with the 3 categories that we had. Now, the 3 categories were upright / inverted. Okay, upright, inverted is the first category. Is our image upright or inverted? Just type U for upright or I for inverted. This image we're seeing here, this green arrow, it is upright, correct? Good, so it is upright indeed. Let's take a look at category 2. Category 2 is magnified or smaller. And just type in M or S, magnified M. Oh, I is incorrect. This is upright, so U is the correct answer. So several people said inverted for the image. That's not correct. This image is upright, and we see that the object is pointed in the same direction as the image. Therefore, it's an upright image. Okay? So let's take a look here in terms of magnified or smaller. Several of you are already answering smaller. That is the correct answer, but it is smaller, obviously. And our last category is this image real or is it virtual? And just a reminder about what that means. So again, it's going to be R or V. A real image is a place where the light is actually coming from, which you could use to record the lights, for example, with photographic film, a CCD, or with your eye, actually the retina of your eye, the light landing on your retina. A virtual image, it looks like the light's coming from there, but it's not actually coming from there. Okay, so thank you for answering. Virtual is correct. So virtual is the correct answer. So we have a virtual, smaller, upright image, which seems like a strange thing. Why would we want that? And actually, we have a pretty common application for this kind of thing that you guys might be familiar with. Anybody? You might have used one today when the DHL person came by to deliver a package. Anybody? Looking hole. Yes. Okay. It's called, I'm not even sure what the English name is. Auf Deutsch is it called the Türspion, the door spy. The door spy. The door spy is, kind of a weird word. A door spy is a weird thing. Der Türspion is, by the way, article. In English, I'm not sure what it's called. Anyway, so a peephole. Is it called peephole? Okay, peephole. Der Türspion. You also use it on a car. Your car might use this, and you might be familiar. Obviously, you guys can't drive, but if your parents drive and they switch off, if they switch off on their backup camera, you might see an image that's kind of distorted of the area right behind the car. But again, the same idea there would be that there are situations where you want to have actually much more compressed into the field of view. This is also known as a fisheye lens, in contrast with a magnifying glass. X official, that's the person I blocked. Okay, so that's what a concave lens has in terms of how the image forms and what kind of image it forms. We're not going to go through the calculation here, but conceptually, I think it is important to realize what kind of image it forms and where it forms and how we see it. Okay, good. Now, we're now at 11:56, so I'll give you the chance to ask questions about how a concave lens works. Hey, Philip. There he is. Okay, do you guys have questions on what we just did in terms of the physics? Okay, I'll ask the other way around. Do you understand what's going on? If yes, type Y and just hey, or yes, Y or yes if you understood what we just did. Okay, so Carly asked, can an image form under the optical axis? Yes, an image can form under the optical axis. So we just basically drew this in order to talk about how this image forms in this case. So we placed our object on top of the optical axis, but if we place the object on the optical axis, for example, then the image would form upside down and it would form across that optical axis. So yes, above and below would work. Sure. So light does come from our side. So for example, light comes from our eye, my eye as observer, to the lens. And then if there's an observer over here, they can actually see me. Okay, so light can pass both directions. but you won't be able to see that light. So if you have the light in your eyes right here, you're seeing this object because the light from it comes in such a way as to form an image here, and that's what you see over there. And of course, on the other side, same thing happens. So on the other side, if you had another observer, they would see your eye forming an image as well. We did not connect the point to the optical axis. It looks that way, but it's not the case. So the optical axis is here, where the butt end of that arrow is, and the top of the arrow is up here. So there's a slight difference. So the intersection point is where these lines intersect, and that's slightly above the optical axis. Okay, so hang on, two questions. So if the lamp was behind us, so let's say we've got a lamp over here sending light at us. Now, the light that comes from this arrow is not necessarily generated by the arrow in the sense of that this is a shining arrow. Most likely, we are best to think about this as just an arrow, a red arrow that receives light. And if the light comes from over here or here or here or here, and then hits this arrow, it doesn't really matter where it comes from. The arrow itself, because it is absorbing the light. So let's imagine our arrow is literally a piece of paper like that. There's our red arrow. That red arrow isn't actually shining light out of its own ability to send light. It's receiving the light from our window. Then the light's absorbed and then re-emitted from this arrow. And that's the light we see. The same thing would be true here. This red arrow here, if our lamp was over there or there or there or there, it doesn't matter, receives the light and then re-emits it. Yes, Aaron, I will take a picture and send it to the group chat. Well, yes, I'll send it to Classroom. What would it look like if you put a mirror on the other side of the lens? Okay, so depends on where you put it. So if you put the mirror obviously here, you'd actually block the arrow from sending light to our lens. That would be bad. If you put a mirror over here, right, we would actually generate an image of our arrow behind here. Okay, and you could also see that. Okay, Mr. and Mrs. Claus. Nice, Lars. Fantastic. Okay, I will send this picture. I hope that helped you understand it to some degree. We can talk more about it next week. We do have another physics live stream next week. We have now 15 minutes. Hi, Molly. Okay, now Johannes did not show up. So wait, so Philip did show up. I banned him, or what the heck's going on? So he did show up as his regular person. Hi. Okay, so he showed up just late. Okay, and Louisa never showed up. Correctly? Correct. Wait, Johannes said yeah, so he's here as well. Did Louisa show up? Yes, I see that. So I have only that Louisa never came. Is that correct? She not here? Okay, she's not here. Okay, so we have 15 minutes to chat. Obviously, oh, there she is. Okay, good. Everybody's here. Good job. So this is kind of limited in terms of the amount of conversation. Yep, everybody's here. I got everybody marked off as present except for Beckley, that guy. Good. With the PhET simulation, good question, Aaron. The simulation, I'm only hoping that by Monday, everybody has it working, that you can use it. That's all I'm asking. So once you have seen that the simulation is there, that you can load the website, or you can download and install the Flash or the application, then at that point, just mark the assignment as done. I want to make sure that's the case before I give the assignment, in order to make sure that you guys can actually do it, and we just don't get caught up in tech help for like days on end because so and so many people don't know how to do that. Okay, so please mark that as done by Monday. Okay, now we have a few minutes just to chat as a homeroom, and I have my own ideas in terms of what would be a good idea. I wanted to propose, and even this idea comes from me rather than from you guys. I'm hoping that you guys think this is a good idea as well. As fun as it is for you guys to watch me on a screen, and then for me to ban you guys for making stupid comments. Maybe it would be good, helpful in terms of community building and maintaining that we would do a social homeroom chat at some point, either on as a Google Meetup or on Zoom or something like that. So what is your sense? Would that be a good thing or not so much? And this would be in addition to, yeah, either Zoom or Zoom. Zoom, okay, that's a yes. Zoom would be good. Okay, you want to do a Zoom? So my idea would be that we would do, yes, okay, that we would do a Zoom meetup. Zoom, okay. We would do a Zoom meetup, and let me just look at the schedule here. Okay. Okay, so Zoom seems to be the majority opinion. So let's aim to have a Zoom chat, meetup. What do they call it? Zoom meeting. Okay, whatever they call it. We'll do Zoom then. And let's do Zoom on Tuesday then. Tuesday, we don't normally have a live chat meeting. Okay, a Zoom meeting on Tuesday. We're slated 13:25 to 14:10 is when we would normally have class. Do you guys want to hang out the whole time? No, we will still have a physics live stream on Friday. Nope, we're still doing physics. We got to do physics. So we're doing 30 minutes physics on Friday would be the plan. And then on Tuesday, we'd hang out just to hang out. Is that okay? I mean, I don't care if it's okay. That's what we're doing. So Zoom call on Tuesday, 13:25. And do you guys want to do the whole 45 minutes? And Friday would be the physics stream. That's correct. Whole 45, 13:25 to 14:10. Yeah, I can do that. It is Friday, Louisa. Zoom. Okay, so on Tuesday, shit. Sorry. It's March 31st, not March 30th. So Tuesday, March 31st, not March 30th. Sorry. Do this again. There you go. Zoom meeting for 9D on Tuesday, March 31st, 13:25 to 14:10. Okay? Thumbs up to that. Okay, that's enthusiasm. I like your enthusiasm. So exciting. Okay, and just to make clear, the Zoom meeting on Tuesday has no academic purpose whatsoever. Okay, so it's kind of your time in terms of figuring out how to hang out together. I'll still moderate it if somebody's being a total idiot. But otherwise, we can just hang out and talk about how things are going or what you want to do. Okay? Yes, I will get a code, and I'll get the Zoom set up set up so then I can yeah, however that works. I've never done it, but I'm sure I can figure it out. So Tuesday I will schedule that a meeting room or whatever it is called, and then you guys can join. Code and password. Cool. Okay, are there any other pressing topics you guys want to talk about? Okay, you guys are being very silent, which is surprising. No, nope. Okay, all right. Okay, iPad. Okay, here's a word of encouragement. If you guys don't have any other questions, I've got the standings for our little competition for which class has done the most homework, and you guys are doing very well. We're averaging 9.07 on terms of our scoring average, and only the 8th grade class is a little bit better at 9.39. So if you guys haven't done the homework and or are missing a part, didn't get full credit because you were missing something on the assignment, hey, wouldn't it be cool if you guys got first place because you're very close? So it would be awesome if you guys could still turn that stuff in today. And then, so the score is 9.07 out of 10. The average, the maximum point is 10 points you can get. You guys at 9.07, 8th grade's at 9.39. And you guys are in first in second place behind them, but you guys can catch up and make it. Okay. If you guys have no other questions, we can end early. That's okay with me. Do your homework. Yeah, that's motivational, Carlota. I like that. That's very motivational. Good job. Okay, I will regularly go through. Yeah, so I will check on that, Emma, to take a look. There you go. If everyone gets a 10, no one can beat us. That's right. So let's see if you guys can do it. I believe you can. Hey, it would be nice if the Blessman homeroom won the Blessman homework competition. That would make sense. Louisa, wait. I'm waiting. Okay, there are new assignments that are also coming due, but the first 2 assignments, these are actually already due. The competition is for 701 and 702. That's correct. So you need to complete those in order to get credit for the competition. We'll have a new competition for the 2nd week's homework. Okay, and then a new competition for the 3rd week's homework. But this is basically the mop-up time. These assignments were already due, and now it's time to catch up. If you missed something or you missed points, then you can resubmit. Okay? Okay, cool. I'm going to hang up, and that's the end of our live stream. So nice seeing you guys. Have a good weekend, and keep working at those homework assignments. I hope if we get to 10.0, that's going to be awesome. But let's see if we can actually do it. Either way, I hope you win. I hope you have a good weekend. Obviously, you can't get too much outside, but do make sure you take a walk or a run or a bike ride or something so you get some fresh air and exercise, and have a good weekend. See you guys later.